Now, I haven't spoken to you about dish yet. Dish has to do with how well centered the wheel is generally between these risers, and certainly how well it will be centered in the bicycle. We'll get to that soon, but let me just mention at this point that when you start putting equal numbers of turns on these spokes, which we have done so far, the rim will drift a little bit to the left simply because the angle at which these non-drive side spokes is pulling the rim to the left is a greater angle than the ones here are pulling it to the right. So my rim has drifted left just a little bit. Nothing to worry about. I can just see it. And so what I'm going to do in the next round of tensioning is tension just the spokes on the drive side. And I'm going to put one additional turn on all of the nipples on the drive side. I'm going to leave the non-drive side alone. Now this is just based on an observation. There's no magic in knowing when to do this or not. You just make an observation as to whether the rim looks like it's reasonably centered or is not, and decide whether to tension both sides of the wheel or just one. When we get into a discussion of dish gauges, this will make a lot more sense to you. Okay, so we're just going around only one turn on the drive side spokes. We're actually making pretty good progress with this wheel. Now let's just spin our wheel one more time just to make sure we got everything the way we want. It looks pretty good, pretty level, very little up and down, and very little left and right. So what I want to do now is to determine what the average spoke tension is on the drive side, and I'm going to use my tensiometer for that purpose. Now that I have the wheel true, I want to balance out this tension on the drive side, but the first step of that is to determine what the average tension is. And so I'm going to go around and spot check with this tensiometer here, and I'm getting readings of about 21 or something like that. That's about at the point that I want to do this balancing out. If I had readings down around 15 or 16 or something like that, that would be too low, and I would put more tension on the drive side spokes to bring them up into the area of around 20 or 21 in order to balance it out. That's probably about 3/4 of the way toward my final goal of about 120 kilograms of force. So I'm going to go around the wheel with this tensiometer and read and write down the tension on each of the 16 drive side spokes and then determine the average. So here we go here. That one is 21. That one is 21. I'm going to write those down. Another 21 here, and another 21 here. So I have pretty good consistency, which is a great thing. And now I'm going to go all the way around in the same way and determine what the average is of all of these spokes. Well, we have some pretty fantastic consistency. Nearly all of the spokes are 21, as you can see. There are only a couple of deviations. One is 22 and one is 20. Otherwise, they're all 21. That's sort of an ideal situation. You don't always get this, but we're grateful when we do. So all I have is a small deviation. This spoke here is a little bit below the average. This spoke here is a little bit above the average. So what I'm going to do is to find those two spokes, and I'm going to loosen that one 1/4 of a turn and tighten that one 1/4 of a turn, and that should bring them both to about 21, and all the spokes will then be consistent. Well, these are the two spokes that were a little bit off the average. This one was a little bit high and this one was a little bit low, and if I pluck them, I can hear the difference. Don't be fooled though by plucking spokes and getting a tone. That is a useful technique, but it doesn't tell you anything about the magnitude, because for one thing, a spoke of exactly the same tone would have a different tension if the spoke were a different length, or if it were a different thickness. So it can be useful, but it can be misleading also. So this is the one that's higher, and this is the one that's lower. I'm going to loosen this one a quarter of a turn, and then the spoke right next to it on the same side of the wheel, I'm going to tighten that one a quarter of a turn, and we'll see if it's any better. Maybe I'll do it again. Maybe I'll just do that again. Maybe another quarter and a quarter. This is somewhat of an imprecise process, but all right, now we have consistent tone, and if I use my tensiometer, I will see that I've got a reading of 21 now on each of these spokes, which makes them the same as all of the other ones. So this was kind of a simplistic process. Sometimes it's frustrating. You have to go around the wheel a number of times sometimes to get the spoke tension evened out. But believe me, it is worth doing it, because consistent spoke tension in your final wheel will have a lot to do with the strength and durability of the wheel. Our average here on the tensiometer of 21 corresponds to about 100 kilograms of force, and that's more than 75% of the target of 120. It's a little over 80%, but my numbers look pretty good. I have pretty good consistency. If I find myself in a situation like that, it doesn't mean I have to loosen the nipples to get the tension down to 75%. If I'm a little bit above that and my wheel still is looking pretty good, 80%, 85%, that's okay. Oh, well, we spin this wheel and it looks pretty good, and that doesn't surprise me. Normally when you're balancing out tension and you add a little tension to one spoke and then reduce tension on a neighboring spoke, will have very little, if any, effect on the trueness of the wheel.